We're given this rectangular prism, which we can see is 25 centimeters long, 10 centimeters high and 15 centimeters wide. And the first thing we want to find is the length of BF, which is just there. We can actually draw out the right-angled triangle BCF, which would be right-angled at C. This length here would be 15 centimeters, and this would be 25 centimeters. So BF squared is going to be 15 squared plus 25 squared by Pythagoras' theorem. So we've got 15 squared plus 25 squared, which is 850. And so BF is going to be the square root of 850, which is going to be approximately 29.15. We now want to find the length of BE. So that goes across the box like that. But we can find a triangle that contains BE. It would be this triangle here, which would be right-angled just there. So let's just draw that triangle. And that would be BFE, right-angled here. Now, BF is what we just found in part A. So that is the square root of 850, and EF is 10. So using Pythagoras again, BE squared would be 850, which is the square root of 850 squared, plus 10 squared. So if we go to the calculator, if I just re-square my last answer, I get my 850 back, plus 10 squared, so that's 950. And therefore BE is the square root of 950, which is approximately, square root last answer, 30.82 centimeters. Now the next thing we want to find, we can see at the bottom here, the size of angle BDC. So that would be this angle just here. And we could use this triangle BCD. So BCD, right-angled at C there. And we know that this is 10 centimeters and that this is 25 centimeters. And we're trying to find this angle here. Now, this one would be the opposite and this would be the adjacent. So, TOA, opposite and adjacent, means we're using the tangent. So the tangent of our angle, let's just call it x. So the tangent of x is the length of the opposite, which is 25, divided by the length of the adjacent, which is 10. So that's going to be the inverse tan of 25 over 10. And so we can calculate that. Inverse tan 25 over 10. 68.2 degrees if we give it to 1 decimal place. Finally, we want the size of angle BEF. Now we have the triangle BEF here, so what we're wanting is this angle here, which I'll call Y. This one is the opposite and the adjacent, so once again we'll be using the tangent. And so I can say tan Y is the square root of 850 divided by 10. So Y is the inverse tangent of the square root of 850 divided by 10. We can calculate that. So inverse tan, square root of 850 divided by 10, and that gives me 71.1 degrees if I go to 1 decimal place.